So what I'm going today to talk about is basically object-oriented language and Golang. But before we'll dive into, I would like to introduce myself a little bit. I already was introduced, but currently software engineer. Currently now in transfer to another company, so no marketing stuff or whatever in the beginning. So sorry. That's why you don't see anywhere company titles. So I like basically create things, open to new ideas, and also some into music. So if somebody is also into me, might talk maybe after. And I'm still part of also GDG Riga and also helping in organization of DevFest Baltics. And what I will share today, I think, is more like a story, and a story of transformation. And basically, this is a story about object-oriented programming and Go, mistakes that I made during the journey, from understanding how to do programming in Go in a correct way, some new ways of thinking because of that, and I hope that in the end of this talk, you will have maybe a will to try Go one more time if you not liked it. By the way, who is here familiar with something like Java or C# or something like object-oriented stuff? Okay, good. Who heard about Go? Like heard. Okay, who is programming in Go? Okay, good. So yeah, if you tried and thought that it's not your, I hope that maybe after this talk you will give it another more go. Maybe even you would like to make it #1 language for yourself when you will do some prototyping or thinking about better design, or maybe even in your company. Or if you're already a Go user, I think this talk might help you to convince somebody to try Go or start programming. And because we're talking about object-oriented stuff, I think I will start from definition of what is object-oriented programming. So according to Wikipedia, object-oriented programming is a programming paradigm based on the concept of objects, which may contain data in the form of fields, often known as attributes, and code in the form of procedures, often known as methods. Or in other words, we can tell that object-oriented programming is a programming language model organized around objects rather than actions, and data rather than logic. And because I will need to compare Go with something, I've chosen for this story Java as object-oriented language to refer to, because I think it is already very classic object-oriented language, and everyone here is also familiar with it. And it's also one of the most popular languages used out there. But what I will talk about next applies to majority of object-oriented programming languages. Just swap Java to a favorite object-oriented language that you like or currently into. So how journey started with Go. So one of our colleagues discovered this language and come to us, and at that time there was no official logo, there was only this mascot, which is currently more popular than official logo. And he proposed a valid thing. It looks like this is a nice language. Maybe we need to do something to create our service inside our ecosystem. And we will do this today. But before, we will dive into development and how object-oriented development differs a little bit from Go development. Let's take a look on a difference between just basic stuff of the object-oriented and Go, and try to make some conclusion, like is Go object-oriented language or not? Can we define it as such or not? And as you know, our world is flat and stand on 3 elephants, and it's a known fact. Same true for object-oriented world, but elephants are different. They are encapsulation. Encapsulation keeps the data and the code safe from external interference. Inheritance. is a mechanism by which an object acquires some or all properties of another object. And polymorphism means to process objects differently based on their data type. And the big question here is that, does Go have all of these to call itself an object-oriented programming language? So Java has all three, so it's truly object-oriented language. In Go, we have encapsulation. We can abstract things freely in how we want. Look on the big projects like Docker or Kubernetes. They are pretty complicated, but still you can find the way in them. Go doesn't have inheritance. Instead, it uses composition, and we will take examples a little bit later. And because of that, Go also doesn't have polymorphism. So it's kind of 50-50. To have full polymorphism, we need to have inheritance, which we don't have. So we can kind of implement it here, and we will take a look on this a little bit later. So let's start with examples of these kind of three language properties and and we will compare them side by side. So encapsulation. So consider this simple class. We have vehicle, we have some brand, we have wheels. So we don't give direct access to the brand and wheels. They are kind of protected. And we have only kind of public methods that can access these attributes. The same thing in Go. Looks like this. So let's already start to find out some differences. I think the first that is kind of on the spot is that we don't have classes here. We have structures. So why is that? Because Go was originally kind of inspired and was built as an alternative to C and C++, so structures came from there. But this is kind of same thing as with classes. Another thing, Go doesn't have access modifiers to encapsulate things like private, public, or protected. Instead, it has exported and unexported fields, which are differentiated by first letters of variables, so methods or functions. So lowercase means that it is unexported, and capital letter means that it's exported. So kind of private, public. So, and these are package level visibility. So lowercase names will be visible inside the same package, but they will not be visible outside. So at first glance, this may seem kind of weird, but after some time you realize that this is a nice bonus to have because it's easier to recognize in your code what is kind of exported and not exported. Okay, the first kind of everything is clear. Inheritance. Again, in a classic object-oriented world, everything is simple. We just basically write that something extends something, and we get all the properties. In Go, as was mentioned, we don't have inheritance. So what we do instead is composition. So here we have car structure, we have vehicle structure, and this is two types how we can embed our structures inside another. So in first one, we're kind of doing anonymous embedding of one structure in another. And in second one, we are assigning our structure directly to some structure field, in here, public field base. And how you assign here will change how you will get access to the methods of a vehicle structure. So for first implementation, you will access them kind of directly. So this is there is a little bit kind of sugar because they're kind of anonymized. So you will access as in object-oriented kind of way, so directly. But under the hood, you access it through some anonymized field. And with motorcycle, basically access through the attribute. Okay, moving to polymorphism. Now, what about polymorphism? How we can change behavior of some method? Again, in Java is kind of simple. If we want to change something, we just override the method of a parent, and change behavior. In Go, we can't do that like such. We need to use interfaces to kind of mimic such behavior. So what we will do here is first, for vehicle, we will add some default methods for the logic, that computes speed. We name it compute speed. Then we will declare an interface called speeder. So, and the car and motorcycle will basically implement this interface. So our, I would say, inherited structures implements this method. In Go, there is no implements keyword, as you already kind of seen. If structure has specified method, it already implements any interface that has same method kind of declaration inside. And how you will use it? Like this. So if you want to change the logic, you just swap the logic inside that method, but without any kind of overrides. And an additional example of usage of interface, you can extract, for example, this printing in some separate function, pass speeder interface or what implement this interface, and you can pass just structures inside, and it will figure out what to do. And a little note on this example here about interfaces. In Go, interfaces are not declared just somewhere, like in separate package or somewhere like we declare interface and some implementation class together. Usually they are declared in place of their usage. So as you can see here, that I moved interface kind of closer to the consumer of this interface. And this is considered as a good practice and a good pattern to use. This works not always, of course, but a good practice. Okay, so what else we have kind of in object-oriented stuff? And I think you already seen some examples. There's some interesting thing about how we initialize instances of structures in Go. So let's talk about constructors. This is one thing that majority of object-oriented have. We can just specify some constructors that will build the instance of your specified class. In Go, we don't have syntax for constructing. What we'll use instead is create a function that will basically do the same behavior. It will construct something and return back something already built for you, predefined. And that's usually achieved with this kind of syntax. So function usually starts with new and what it will return. And consider following example. And we are creating an instance of a class, passing it to print speed, and it is empty, and we're not passing anything inside. So the question that raises up here, will it work, or it will blow up with some error? So it will work, and it will print us 0. Why? The question is. Because in Java, usually if you not initialize something and in runtime something will try to access what is not there, you will get famous null pointer exception. But in this case, no exceptions. Why? Because Go has default values, or in other words, empty values. So everything is initialized to something. And I think it is a very good feature. So in previous example, our vehicle was initialized to these things. So brand was initialized to empty string, and wheels was initialized to 0. That's why we didn't have any errors at all. And this is also a good thing to use when you write your code to modify maybe some logic, because you already know that variables have some defaults. So what else object-oriented languages have, like very valuable? I think enums. Enums is a quite powerful data type to present enumerated data. So again, in majority of object-oriented languages, we have something like this. So we have separate type, enum, and that's all. And it will enumerate data for us. In Go, We don't have separate data type, we use constants. But benefit of using enums is that we don't define order explicitly, right? And it is an awesome feature to use. Very helpful in refactoring when you need to move stuff around. So can we have something similar in Go, like enum type in Java? Yes, we have. We can use this JOTA identifier, and this will produce the same result. But Go's JOTA identifier is used on kind of in const declarations to simplify definition of incrementing numbers. But another massive feature of JOTA that I will not cover here today is that you can use it also in expressions. So it can not only do incrementing of numbers, but you can use some logic with it that will produce some different enumeration logic for your constants. And in each constant block, JOTA, of course, is reset to 0. So I think we have kind of check marks on this one. Another hot, kind of popular topic, generics. So Go currently doesn't have generics. So this is, I think, is a good point and a bad one at the same time. There are currently some drafts in a second version, so you can read more about what's happening there. But currently, in communities, there are still some discussions going. OK, what else? Exceptions. Very common way to throw kind of errors in object-oriented languages around. But in Go, there are no exceptions. There are only errors. They are handled as follows. So this is a common pattern that you will see that function returns two values, like original value and an error value if something kind of happened. Yes, this kind of leads to verbosity and seems like why you need to do that if we can throw something and catch it somewhere kind of else. But in my opinion, verbosity in a such way is more kind of transparency and you have more control. Somebody who knows Go here may tell that there are panics in Go, but panic typically means something as similar as exception, that it should be used only some exceptional cases. But I think for majority of developers, as for example me and majority of us, panics are not for us, not for you, because they really should be used in something edge case situations like out of bounds, and they're usually kind of thrown or run by standard definition libraries in Go. So okay, at this point, I think we looked a little bit around and compared these two different types of languages side by side. And I think we can come up to the conclusion that Go is not an object-oriented language. But then what is Go about? So I think, in my opinion, Go is about simplicity, minimalism, transparency, and predictability. And I think that's why big companies and some products, I think you're familiar with some of them, like Docker, Kubernetes, or HashiCorp stuff, and some others that are not mentioned here, use and big heavily on Go instead of something like C# or Java for some reason. With this in mind, let's return to the idea of writing our service. So our service will be very simple, do no complicated stuff. And what we needed is basically a service that stores and renders some information, simple routing, RESTful API with JSON and body, and for database, for example, we have Redis. After we know what we want to do, we start to choose tools, right? So if we will take in mind, like thinking of choosing tools in object-oriented kind of programming, so we will end up collecting some libraries. We for sure will need some dependency injection containers because, yes. We need some tools for testing. And basically, what we're searching for is a framework, right? Because framework collects kind of all these tools together, and we are happy to use this. So let's think about how we will write the service in Java. So if we will go with a framework route, I think we will finish up choosing this one, very kind of popular one. And I think a lot of applications kind of use this one now. And let's start to write our service. I will start with a controller. So what's happening here? Very simple, classic routes. We have annotations that do a lot of stuff for us, so it's more like annotation programming, but not the real programming itself. We defined some DTO and DIO. So DTO stands for data transfer objects and data access objects. So this is how, on the left, basically, what's the JSON we're working with, and on the right we have an entity that we will persist to our database. Because we need to persist something, we need to have a repository, and this is how we will create a repository in Java. We just write a repository annotation, and it implements some CRUD repository and something happening behind. Then we need to wire this up to some business layer logic. So we write our pages service that is doing all heavy lifting and will look something like this. As you see, we use this outwire annotation, which is basically our dependency injection container. So all dependencies are already kind of wired for us. And let's go back to controller, connecting our service, boom, done. So our structure of a project looks like this. All classes are in their places, so controllers with controllers, repositories and services are all in their place. Okay, good. So what is good for this thing? So framework was used. It was fast and easy to develop, really fast. Dependency injection out of the box, also nice. Bad things. I have this unicorn because there is, I think it was like a lot of magic happening there. So annotations. For me, annotations is kind of really too much of abstractions and not too very transparent thing to see. So this code is not transparent for me. You're adding annotation, and you need completely to trust this framework and how it works. And if you need to modify something, you need to go through the big chunk of documentation and then try to kind of figure out how you can change it. So I think bad things in this case, and what a lot of object-oriented programmers and developers like to do, they like to abstract things, and they start to abstracting everything to some level that is too high. But it's easy, right? And there is a nice quote about what is simple and what is easy. So simple, a line of code that does something very small and specific, and easy, a line of code that does a lot by calling a framework function, causing thousands of lines of code to be executed. So I think majority of current object-oriented programming way is about second thing. So now let's try to do this in Go. So the first mistake that I did, I thought in not a Go way creating this service. No, I was thinking as an object-oriented programmer. And I started to write some services as I used it to do in, for example, Java language. There are also, you can find on the internet, such articles like learn Go as a blah blah developer, put any language there, like Node.js, PHP, Java, whatever. In my opinion, in this case, this is a bad read and a wrong path. And I think more correct way of learning would be for you, if you're just starting, would be look around before diving in. There is a very big community in Go. You see currently on screen few Twitter handles that you can follow to get deeper into ideas and good practices. And basically start learning Go as a Go developer and from Go developers. I think this will be the better way. In Java example, we used a framework, remember? So this was my second mistake. So ask yourself, really, like when you be one-on-one with you somewhere, why you need a framework in such case? We have applications with 5 routes, only 5 routes, 1 database, 1 model. Why you need a framework? Another thing is that Go has very rich standard library. It's very powerful. And I think you read more about it and use it. And of course, there are also other libraries currently very kind of popular that easy your job. And also remember about simplicity and minimalism, and that you only have maximum 5 rows here. So for following example that we will do, I will use only one, I think, separate library, okay, 2, for Redis and routing. Basically, for routing is a library that is used by frameworks, kind of in Go outside. Okay. So let's start. Right. The first thing that we will do, I will create this API package that will be responsible for accepting requests. And what we have there, we will have a storage and a server. Storage is our package that we will gonna write. Server is an HTTP server from the standard library. We'll create our routes. We're registering our handlers down there. We also need somehow to start our API. So yeah, this is basically, we need also the constructor function, because we need to pass a storage inside of the API. We need to start our server. So we are creating server, where it will listening, booting our router, and returning the method that will basically start our server with a listen and serve. And another thing, I think, after some time, when application will finish its work, we want to shut down our application. So this is how you will kind of do it. Now let's wire all the things into our entry point in our main Go file. So we will start with our API. We will pass the storage a little bit later. So now to start, we need to provide the port. How to do this more kind of correct way? We can use a flag package. So we can define already some default, like port 8080, or we can pass a flag named port with a different port number, and it will be kind of handled. The second thing, we need to start our server. Okay, this is how we will do that. So we are basically starting our server. Down below, if we will have some error, which is not the error server closed, we will exit with not zero code, and we'll print some error. Otherwise, everything will finish successfully. Now we also want to shut down the server. You know, if you're familiar with, and you are, with object-oriented languages, there are some specific methods provided by the language or by the framework that allow you to do some like clearer shutdown, and like to perform the graceful shutdown. Here we can use Go routines, and your shutdown basically will look something like this. So we are listening for signals that are coming to our applications. We are waiting for sigterm or interrupt signals, and only after we will receive this Control-C on your keyboard, our application will start to perform shutdown, graceful shutdown. And I think this is a pretty neat way comparing to writing or overriding some methods inside of something. I think it's more clear and transparent on what's kind of happening here. Okay. Now we are ready to initialize our storage. So we are creating instance of Redis. We're passing Redis to storage and storage to our API. Everything wired? Okay. So how our storage looks like? It only has this Redis as a dependency, like this. Our page model looks as follows, the same as we did also in Java. And we also specify this kind of as a field tags. It's marked behind, like, so that our values are stored behind these titles, like ID, title, and description in the JSON. This is the JSON names. Okay. So next thing, let's look at an example of a function that we will, for example, use for retrieval of a page by ID. So it might look something like this. So a little bit more verbose than in Java way, where we have one line of code and from repository, and that's all. What we're doing here is basically we're getting bytes from Redis by this key. If everything is okay, we're going down and trying to unmarshal this bytes to our page object, and then we will return. Or on some step, we will just fail and return an error value. And I want to notice here for you an interesting pattern that you may also use in any other world of programming languages. As you can see, the green lines that I currently outline on the screen is a successful path of the execution of your program. And everything that is kind of failing is always going a little bit inside. So I think this is a good pattern of worth taking a note. So now we need to wire the storage into our handler or controller otherwise. And this is how we will do. So we are grabbing some ID by name, we have our storage, we try to decode it to our page structure. If not, again, we're returning some errors. If everything going away, we are updating page by ID and returning our response. That's all. So what are these functions like awk response and write? So awk response looks like this. It's a function that basically returns bytes, because why you need to create a separate object that represents you a response message, then you will pass it to some encoder, and then it will return bytes if you know how it already looks like, and it's not so complicated. And writer function is basically a wrapper around default stuff, so we will always return application type JSON. We will always want to have some status code, and we want to handle the error from write, but not to destroy our application. Okay. So this is kind of how writing of this application will happen. So how the structure looks now in Go. So structure of application looks like this. So we have API package, we have storage, and we have entry point like main Go. And I think you already noticed the difference between object-oriented layout style and the current one in Go. And this was another mistake. I organized around objects rather than actions, and data rather than logic. So here we organize everything other way around. Instead, we organize around actions and logic, so it's more kind of like a demand-driven design. So summary, I think it's rather simple maybe and straightforward, because we see execution of everything what is currently happening in our code. There is also one way of doing things in Go. So if you kind of created this API thing once, in majority of cases, it will be already in all of your applications the same thing. And comparing to Java, there is only one way of doing the same thing. So for everyone else, it's also kind of simplifies the way of development. I think because of this maybe like verbosity that you see, that each step, what's happening, it's also transparent for you and for everyone else, because you don't need to search where is this exception kind of handled if something is going wrong. And what you also seen that dependencies were defined explicitly in the main Go file. Yes, there are some dependency injection libraries that use some reflection stuff, as also in Java. But again, why you want to use these libraries if you can just specify and wire everything, and it is not so kind of complicated. What is bad? I think verbose, as you can see in that you have a little bit more code comparing to like current programming in Java. And sometimes it's too obvious, it starts to be boring, because when you look in different code bases of even big projects, they look like the same, all the same, and you're like, where are streams and some functional programming happening? And going back to the quote of simple versus easy, I would say that Go is easy, because we specify some direct lines of code and we see what's happening. And this is some simple language with no magic. Like it works and it's doing what you really wanted to tell it. And in this sense, I also think that Go is a sobering language, in the sense that it has all good practices from different kind of languages. It's very limited languages with its functionality, and it basically makes you a little bit better developer even if you will just write Go for some maybe your home projects or for some little projects at your work, and grab ideas from Go and maybe transfer them to some big object-oriented programming projects. And one example of this limitation that I can give you is, for example, Go doesn't have ternary operators that are maybe for some people that are heavily used. They have only if-else statements. So please don't do something like this. Don't try to re-implement ternary operations on your own, okay? And because this talk was not like introduction into this language, I very suggest you to maybe go through these other talks, or there are also YouTube channels, and go through them, because they have a lot of interesting ideas and materials discussed. And I think after that you will feel yourself that Go is a nice language to try and make it in your favorite 2 or 3 languages in your pocket. So, thank you very much. That's all.
I think we have time for one question or 2. Is there a question? Yeah, all the way in the back.
If I started a startup today, why would I use Go over JavaScript? Go looks basically like a kid's version of JavaScript to me. Or
why you would like to? Why you want to use Go instead of JavaScript?
Yeah. I'm just trying.
Okay,
honest question. Why is it better than JavaScript? Node.
Yeah. So in my opinion, it will be better because JavaScript initially was not a server-side language. It is it's a language for browsers. So if you, this is kind of the first thing. The second thing that I'm thinking is that Go was designed to run minimalistically and on your kind of servers, and when you will use it, it will compile to some binary to your some system that you want, like Linux, Windows, or Mac OS. So you'll have some little binary, almost no memory kind of footprints. And I think if you, so again, it also depends on what you will do, but I think in Go it's a lot easier to write some asynchronous operations using these Go routines.
Yeah, but then when you go to hire staff, I find it way easier when I have front to back JavaScript, one language to hire staff, and not many people, I feel like I would have problems hiring Go developers. Do you think it's still worth taking the risk to Go?
I think it depends on what you're doing, but yes, with Go you will be more, I would say you will be more safer if you will do some more very system stuff.
Yeah, JavaScript is dangerous, yes.
Oh, yeah.
Okay, ladies and gentlemen, we can thank Sergey for his talk. Sergey, you can clap
Thank you.
again. This is for you.
Yeah, thanks.